Hello, I am Yannick Moy from EduCore, and this month I'm exploring with you the dreadful possibilities that arise with an automated-based plane consisting of wings, tanks, engines, a plane of course, and a pilot. And see that each one of them has three possible states. So for example, the pilot can be awake, drowsy, or even asleep. And there are restrictions on the possible transitions in this automaton, which are expressed directly in the code in the form of assertions, pragma precondition or postcondition, which are defined in the GNAT compiler, or the successors, the pre and post aspects that ADA 2012 defines. And these apply to subprograms, of course. So here is an assertion in the code, and a pragma precondition that applies to this subprogram, and finally a pre-aspect that applies to this program. So let's see how this code satisfies its contract by calling CodePeer. Well, CodePeer detects a number of problems. So let's look at this first one. It has to do with the failure to respect the post condition when calling plane the transition. Indeed, plane the transition has a precondition here expressed as an aspect, which says that the argument new state should be equal to in distress whenever the current state is so. Here in the color it might be the case that we are in distress, so the argument new state shouldn't be equal to on trajectory here. So we are going to remove this constraint by modifying the function transition. We're going to modify the implementation of transition here. Then the precondition here becomes a postcondition. And note that we have to use the special attribute all here to talk about the previous value of current state. And here we can refer to the current value of current state in the postcondition. So let's see, by reanalyzing with CodePeer, indeed the two errors that we had here disappeared. Looking at the second error, it has to do about another precondition failure when calling wings the transition. CodePeer computes the precondition that either one of new state or the current state has to be under stress when calling this function. This precondition look is directly originating an assertion in the function transition. At the point of call here, neither is true. Indeed, current state is equal to bad vibration, and the parameter is equal to normal condition. So that's incorrect. Let's change that. The third error is about some dead code that CodePeer detects here. So CodePeer detects that new state cannot be equal to awake at this point. It's a quite subtle reason, so let's simulate the function calling transition with new state equals to awake. If current state is equal to awake, then the function returns here. So it proceeds with current state different from awake. Then new state being awake, it goes to this branch and it calls treat emergency. Now if you look at treat emergency, it has a precondition that current state must be equal to awake, and this originates directly in a pragma precondition here. So there's a problem. CodePeer detects that, and the problem is that the pilot may have to perform some actions even if new state is equal to awake. So this if is false here. So the correction is simply to remove it. The fourth error is about a postcondition failure on this function. And if you look at the declaration of decreased stress, it has a contract expressed in ADA 2012 syntax, saying that it should be called when the current state is not minimal, and it should result in a current state not maximal. And if you look at the body of this function, the problem is that it starts with a stress not minimal, it increments by 1, then it has to end in a current state that's maximal, because there are only 3 levels here. And the problem is really that this +1 should be a -1. So let's run CodePeer for the last time. And you can see that we have solved all our high and medium problems. So we're almost safe now. Hope you enjoyed this demo, and see you on www.adocore.com. Thank you.